students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for another session in surface chemistry. Today we shall see about the mechanism of enzyme catalysis. Okay, let's move into the topic now. Actually, in 1894, Fischer suggested a lock and key mechanism to explain the working of an enzyme as a catalyst. Actually, he is the scientist who suggested a lock and key mechanism for the enzyme catalysis. An enzyme catalysis reaction involves the following steps. Actually, there are three different steps involved in this enzyme catalysis mechanism. And the first step goes like this. The binding of enzyme to the substrate to form an enzyme substrate complex. Here substrate represents the reactant which we are using. Okay. So this is the enzyme and the substrate. This two forms a complex. So enzyme substrate complex is formed in the first step. Okay. And actually during the second step of product formation in the complex, that is this enzyme will be combining with the substrate to form a product, and in the third step the release of the product from the enzyme. So in the third step, from the enzyme product complex, the product will be released from the enzyme and the enzyme will be left free. So these are all the different steps involved in the mechanism of enzyme catalysis. Now we are going to see this mechanism of enzyme catalysis in detail. Okay. Actually, there are a number of cavities present on the surface of the enzymes. See, all the enzymes will be having some cavities. Okay. See, these are all the cavities. These cavities are otherwise called as the active centers. Okay, the cavities present in the enzymes are otherwise called as active centers, and these cavities have a characteristic shape. See, these cavities will be having some characteristic shape. Okay, this is the enzyme, and they will be having a specific shape, right? And have active groups like NH2, COOH, SHOH. So any of these groups will be present in these active sites. Okay, so those groups are called as the active groups. So as mentioned above, an enzyme molecule possesses some active sites or cavities on its surface. These active sites are responsible for binding the reactants. Okay, these active centers are responsible for binding the reactant molecule to the enzyme. Understood, students? Now, so the molecules of the substrate which have a complementary shape fit into these cavities just like a key fits into a lock. See here, this is the enzyme and it's having active sites, and this substrate is also having the same type of a shape, so that this substrate can fit into this enzyme just like a key that fits into a lock. Okay, the active site of a given enzyme is so shaped that only a specified substrate can fit into it. Okay, in the same way as only one key opens a particular lock. Understood? Right. Now, on account of the presence of the active groups, an activated complex is formed, which then decomposes to form the products. Understood? See here, an activated complex is formed due to the presence of the active groups. So already we are having some active groups like NH2, COOH, SHOH. All these active groups are present in the enzyme. Okay, enzyme's active sites, right? That's why it's called as active site. Now, since the substrate is getting fit into these enzymes, it forms a complex. And now, after what happens, which then decomposes to form the products. Afterwards, the third step, the enzyme is giving out the products. Okay, and finally, the enzyme is free now, right? So this is what happening. Now, let me explain with this image clearly. So actually this you all know, right? This enzyme is having the active sites and the substrates are also having a particular complementary shape as that of the active site, so that it can easily fit into this enzymes. And finally it is forming an enzyme substrate complex like this, is it not? In this complex, the substrate molecules are placed in the right orientation. Correct orientation. The substrates are placed in the correct orientation, which not only facilitates the occurrence of the reaction, but also it enhances the rate of the reaction tremendously. Can you understand? It not alone helps the occurrence of the reaction, but also it enhances or it increases the speed of the reaction. Okay. Now what happens after achieving the proper orientation? The substrate molecules reacts to form the enzyme product. Understood? After forming the proper orientation, this enzyme and the substrate complex will be forming the enzyme product complex. Okay. Now what happens? The product molecules which is sitting on the enzyme, that is surface of the enzyme, will have no affinity for the enzyme. Can you understand what I am saying? So actually the substrate which is sitting on the enzyme that will be forming a product first, and then this product which is formed will not be having any interest to sit on the enzyme further. Okay, so it will be having an intention to go out of this enzyme. Can you understand? So leave the surface of the enzyme as soon as they are formed. Then what happens? This now what happens? Immediately the products will be going out. So that the surface of the enzyme, so that the surface of the enzyme molecule again becomes free. Now it becomes free to bind up the fresh substrate molecules. Understood? Thus, overall, the enzymes will be lowering the energy of activation of a particular reaction by providing an alternate path by lowering the activation energy. Understood? So, this is the mechanism of enzyme catalysis. Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita Raj, your chemistry mentor, signing off from you. Thanks for watching.